Hey, sunshines. We're going to graph systems of inequalities. So, your first step is to write your equations in slope intercept. So, I'm going to do my first equation in green. So, slope intercept form just means you have to solve for y. So, I want to get y by itself. So, I'm going to subtract a much smaller pen. And a much darker green. Let's just do purple. So I'm going to subtract 3x from both sides. So now I have negative 4y is less than, always put your x term before your constant term, negative 3x plus 4. That 4 was positive, so it's going to be added. That negative sign is attached to that x term. Now I still need to get y completely by itself, so I have to divide by that coefficient, negative 4. So I divide everything by negative 4. So that cancels out. Now y is truly by itself. You flip your inequality sign if you divide by a negative. So I get y is greater than negative over negative is a positive. So my new slope is 3/4, 3/4 times x. 4 divided by negative 4 is going to be negative 1. So now I have an equation in slope intercept form. And I'm going to do the same thing for my other equation, but I'm going to use a different color. So you always want to use 2 different colors, one for each equation. Because when you go to graph them, you need to be able to keep track of which one is which. So subtract my x term. 2y is less than or equal to negative x plus 8. Divide by 2, divide by 2, divide by 2. Y. We don't flip it this time because we're dividing by a positive number. So y is still less than or equal to negative. Remember, you have that invisible coefficient. So this wasn't really negative x, this was really negative 1x. So negative 1/2 x positive divided, that's not a negative. Positive divided by a positive is still positive. 8 over 2 is 4. So now I have my, oops, now I have my inequality solved. So now we're going to actually look at each equation. We need to graph the y-intercept. So that's this, your b, your constant. So you go to that number on the y-axis. Remember, that's -1. -1 means I'm dealing with a negative. So I go to -1, get the pen tool, and I'm going to put a big dot here, a big purple dot, because we're working on the purple line. And then you're going to graph your slope. So my slope is positive 3/4. So that means I go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, and then I get cut off. And then I'm going to go the same backwards. 1, 2, 3, down. 1, 2, 3, 4, backwards. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. And then again, we get kind of cut off, but we want to be able to finish our line. So I'll put the dot there. So the next step when you're graphing a linear equation would be to fill in the line. But because this is an inequality, we need to look at whether it's a dashed line or a solid line. So for an equation, you're dealing with a line that's equal, so it's a solid line. But for these, for this equation, y does not equal 3/4 x minus 1. Y is everything greater than that, but it does not include that. It's not equal to that. So it's going to be a dashed line. A dashed line is when you have greater than or less than, but not equal to. A solid line is when you have the equals, when you have that little line underneath. Also, an actual equal sign would be a solid line, which means you're not going to shade, but sometimes you might have a system where you're dealing with an equation mixed with inequalities. So a solid line is anything that has an equal sign in it. So the little extra line underneath your inequality or an actual equal sign. So this is a dashed line because it's not equal. So I'm going to fill in a dashed line using my line tool. We're going to insert a line. And then we switch to our select tool, and I'm going to actually adjust it because it's a little bit off kilter here. My endpoints were a little off. And then I'm going to change it to a dashed line. I'm also going to add arrows because it's a line, so it goes on forever and ever and ever. And I'm going to make it a little bit narrower so we can see what else is going on in our picture. So our next step is to shade our inequality. Our actual solutions to this inequality are all of the points either above or below that line, because you're saying that y is everything. In this case, we're saying greater. So above is going to be everything greater, below is everything less, because y is that up and down. So my solutions are all of the y values that are higher than this line. So if y is greater, then you shade above. Now, because this is a system of inequalities, I don't want to shade the whole thing in completely. I'm going to give a couple of light lines just so that I can see where I'm dealing with, but I don't want to shade it thoroughly because I only care about the points that are solution to both equations. So next, I need to do all of that for my other equation. So my y-intercept is 4, so I'm going to go to 4. 1, 2, 3, 4. No, 1, 2, 3, 4. I'm going to plot my point, and then my slope is -1/2. So I'm going to go down 1 over 2, down 1 over 2, down over 2. And then this time it's or equal to, so this time it is a solid line. So I'm going to go to that line tool. Make my line green. I'm going to keep it solid, but I am going to add the arrows. Now this time y is everything less than. So I'm going to shade below. So everything underneath the green line is a solution to the green equation. Everything above the purple line, pink line, is a solution to the purple equation. But I only care about the solution to this system is where it overlaps. It's the intersection of the two solutions. So it's the area that both are true. So it's the area that has both colors, the red and the purple and the green. So that's the part that we color in really, really thoroughly because that's our actual solution. So any point in this area is a solution to the equation. So I can choose any random point and say, okay, 0, 0 is in that area. 0, 0 is a solution. -4, 3 is a solution because it's in that area. You can pick any point in there and it's going to be a solution.